Our next presentation is proving the value of telementoring using wearable technology to teach complex surgical procedures, a prospective randomized trial to be presented by Dr. Huang.
Thank you so much. Good afternoon, everybody. Which button is it? It should be. Perfect. Thank you so much. I have no disclosures. So as we all know, since we're here at SAGES, the pace of technological change in surgery is really unparalleled. We've moved from the 1980s and earlier with a large incision down to tiny 5-10 millimeter incisions and onwards. As we move forward and want to learn new methods of operating, new systems, new technologies, the classic maneuver now is the surgeon X goes to a training center, they learn this new procedure, they demonstrate competence at this outside facility, and they go back home to their own institution to perform this new procedure. The issue remains that at their own institution, they now have little to no support after leaving the training center that they've learned this new process at. So telementoring is where this has come into play, as Dr. Dunkin and several other people across the nation and world have started working on. So the question that we pose is, can telementoring be used truly to effectively teach complex surgical procedures, both within a state, a nation, or across the world? At our institution, to look deeper into this, we enrolled PGY 4s, 5s, and minimally invasive surgery fellows. We normalized their knowledge and technical skills through didactic programs and also validated their laparoscopic skills with an FLS model. We then randomized them into 3 groups, one being a non-mentored group, the next being a telementored group, and the last being a in-person mentor, all of them powered with an N of 5. We evaluated them in an experimental operating room setup over at Houston Methodist Hospital, and we had them all perform a laparoscopic left colon resection. For the telementoring system, at Houston Methodist, we developed a wearable telementoring platform which has two-way audiovisual communication, allowing the mentor, in the bottom right seen as Dr. Dunkin, allowing him to both see what the mentee is doing during the operation and also be able to tele-illustrate back on the laparoscopic video feed where he would like the mentee to cut, what he should be aware of, and what is the next step of the operation. The results were quite interesting. Both in the telementor and the in-room mentored group, they had similar goals, metrics, values. And although the non-mentored group seemed to have a higher goal score, the safety on that group was significantly lower. At 60%, it was completely unsafe to perform on a live person. The both telementor and the in-room mentored group were both at 100% of safety, and in those 2 groups, the lymph node yields were clinically relevant at 12 or higher. As you can see in the non-mentored group, the lymph node yield was suboptimal. So as we move forward with this project, we wanted to see what the effectiveness of commercially available fixed and wearable telementoring platforms would be, and also what's the utility of a structured communication protocol while telementoring. As we move forward on this project, several new types of technologies, wearables came on the market, and we wanted to vet these and see, are these viable methods to do telementoring? To answer the latter question, we collaborated with the LAPCO organization, a national training program of laparoscopic colorectal surgery based out of the UK. What LAPCO has done is they create a new system and a method of in-room standardized communication protocol where they are able to teach and mentor a mentee through an operation while minimizing the inherent nature of the mentor wanting to take over a case during the operation while trying to teach the process. While learning about their methodology, we realized that this was perfectly suited for the telementoring platform, and so in collaboration with them, we created the MITIE-LAPCO program. For this portion of the study, we had 2 PGY3 surgery residents mentored by 9 LAPCO-trained expert surgeons, and we had the PGY3 surgery residents perform cadaveric laparoscopic right colectomies. The 2 telementoring platforms we used for this procedure were the Karl Storz Visitor 1 system and the Google Glass system, which was loaded with HIPAA-compliant video conferencing software from a company called Pristine. These are the 2 platforms here. I'm sure we've all seen the Karl Storz Visitor One system in the exhibit hall, and Google Glass has been in the news quite a lot as well. So our results. Based on structured interviews, the LAPCO experts that took part in the study felt that the LAPCO mentoring communication protocol was ideally suited for telementoring. A lot of the same methodology that was developed to promote surgeon independence in the OR for in-room mentoring were perfectly suited for telementoring. The other thing that we realized during this was that the setup of the equipment in the operating room was extremely important. The LAPCO communication protocol really tries to minimize dual task interference, which in the operating room is exemplified by trying to teach while operating and doing both things at the same time. So we found that in the operating room, by placing the Visitor One system, or our audiovisual communication system, 30 degrees offset from the laparoscopic video feed, it forced the mentee to take their eyes off of the laparoscopic feed and thus automatically stop them from operating to turn around and see what the mentor was trying to show them on the video screen or what to tell them for what the next step would be. So this was a great way to both maintain a level of safety in a telementored setting where there's no surgeon there to physically hold the hand or put something in front of the operative field, and also maintain effective communication. A little bit counterintuitively, both the systems, including the Google Glass system, have this dual task interference built in because of the way the video screen is placed and projected within the wearable unit of Google Glass. The wearer has to unfocus from the laparoscopic video feed and refocus on a small video screen in the right upper corner of their field of view, and so in many ways, essentially taking their eyes off of their operation to see what the mentee or the mentor is trying to say or demonstrate or illustrate to them. So after this study, we did a comparison of Glass versus Visitor One. In the red arrows, you can see that Google Glass was not unexpectedly more comfortable to wear and allowed a greater range of movement for the wearer. But overall, Visitor One had better audiovisual connectivity, the ability for the mentor and mentee to have a audio and video communication system, and in general, the overall effectiveness was superior in the Visitor One system. As we did a much more direct comparison on this Likert scale, we did see ultimately that the Visitor One system was superior to at least this iteration of Google Glass during our experiment. So in summary, telementoring can be used to effectively teach complex procedures. The LAPCO communication protocol that we've developed and adapted to telementoring is really ideally suited for that field. And Visitor One system is a really well-created system for telementoring, and in our studies was superior to Google Glass for mentoring in the operating room. But talking to the LAPCO expert surgeons, they did feel that although the Google Glass system maybe didn't have as good audiovisual communication, maybe didn't have as good resolution, they still felt that it was adequate enough to allow for safe mentoring of somebody through an operation in a remote setting. And these are my acknowledgments. Thank you very much. Happy to take any questions.
Yes, back microphone.
Hello, Carolina Jimenez from Toronto. So I wanted to ask you about the battery life of Google Glass. So one of the issues we've encountered is that either it heats up and it freezes, or it just doesn't last too long, and you have to have the cable plugged in, which cools actually the glass and affects the view. So do you have any comments, and how did you address that?
Yeah, I think I heard it. So, well, thank you very much for your question. And a lot of those issues are what led to some of the limitations, at least in that version that we tested. We did the same thing as you had alluded to. We had to plug in a battery pack to allow for a longer battery life. One of the things that we used in this version for this test is by using custom software from this company called Pristine in Austin. They use a slightly different algorithm and video processing method, so the video feed was a little bit more reliable and it lasted longer. That being said, we did run into the same issues as you. After about an hour or so, we would sometimes get a overheating, and then we would have to swap out the units. So we did have two. We know that as we move forward in the last 3 or 4 months, there's already been multiple companies that have come up with new video projection systems, wearables, heads-up displays, HoloLens, and other things like that. So in this situation, we sort of use Google Glass as an example of a wearable technology. We know that all these things are just, in many ways, just hardware issues that can be resolved or will be resolved as time goes on. And so we just wanted to see is, can we still use this in a controlled setting like the operating room? And it seems like it does demonstrate some promise.
Thank you. Nicely presented.
Thank you, sir.